A card is at rest in the start. That's why its initial speed is zero, and a force, a constant force, start acting upon this card, due to which this card was accelerating with a constant value. That's why it is called uniform accelerated motion. And we know that in the uniform accelerated motion, specifically for this example, if I draw the displacement versus time graph, then its graph is increasing exponentially. So in this question, you have to find out the right kinetic energy versus displacement graph. Note the kinetic energy versus time, kinetic energy versus displacement if it covering the displacement s during its motion. So this motions graph will help us to find out that exact answer. Now we know that as it is, the displacement is increasing exponentially, so the tangent at all the points are also becoming more and more steep, which is telling us that the velocity time graph should be a straight line. And when velocity is increasing from zero to some value, it means the kinetic energy is also increasing. So displacement is increasing, we saw from the displacement time graph, and velocity is increasing, we saw from the velocity time graph. It means that the work done by this resultant force is changing its kinetic energy, but there is a no change in the potential energy because it is moving in the horizontal, on the horizontal surface. And if we write this is a resultant force, so Fs is equals to 1 over 2 mv square minus 1 over 2 mu square. And you know that this is 0 because it has started its motion from the rest. And this is the kinetic energy which we want to plot on the graph versus displacement. And in the start, as I do you remember, I said it is a constant force, which means that acceleration is also constant. So we can say, so this force is constant, which means that we can write now the kinetic energy is directly proportional to displacement. More and more displacement will increase, more and the more speed it will gain in this direction. That's why the graph should be straight line like this. Now I'm also mentioning here the alternative method, that is by the kinematic equation. So you have the two options. So option D is the right answer. Kinetic energy is varying linearly.